All right. Thank you all for being here in iBio or perhaps at home in your nice cozy space at home. We're happy to have you however you're here. This is one of our integrative environmental health sciences seminars. We have a series, as you know, and we've got quite a few more to come to finish off the year, and we've had quite a few till now. But I am especially interested in the one that the seminar we're going to be hearing today. Our guest speaker today is Dr. Nadia Saadat, and she is a research investigator at the University of Michigan. I think she works out of the Department of Pediatrics there. Just a little personal note here. I had a chance to meet Nadia through an event that was held here at Wayne State University about 2 or 3 months ago. It was part of the RU4M Livable Futures event, and I know many of you in the audience were at the RU4M Livable Futures. And at the table that I was at, Nadia was at that table, and it was a great opportunity to talk with her about PFAS. I found out that she is doing a lot with PFAS, especially looking at the implications of exposure to PFAS by pregnant mothers and what that means. And of course, that ties in very well with our CLEAR center here at Wayne State. So I thought it would be wonderful to invite her in to talk. Her research focuses on applying comprehensive integrative approaches to examine how the prenatal environment and metabolic factors influence pathways that affect the baby's growth and pregnancy outcomes. She is studying changes in maternal metabolic profiles and inflammation during pregnancy and the impact of maternal environmental exposures and stressors. She has expertise in using omics and multi-omics approaches to uncover patterns and trends in big data. Nadia earned her MS and PhD in nutrition and metabolism from Wayne State University and was selected as one of the 3 postdoctoral scholars with Rebuild Detroit, the Rebuild Detroit program. Later, she received postdoctoral training in maternal and child health and developmental origins of metabolic diseases at the University of Michigan. There is quite a bit more that I could say about Nadia, but I think I just want to add that Nadia has quite a connection besides just her degree to Wayne State University. I know she's teaching epidemiology as well as, I think, some other courses out of our Department of Public Health.
I'm currently epi right now, but I have taught for MPH also.
Okay, excellent. So, welcome to Nadia, and if you have any questions, please send those through the Zoom, and we will get them. And those of you that are sitting here, save your questions, and we'll get you at the end.
Thank you for inviting me, Carol, and I'm so honored to be here, especially to my alma mater. I received my PhD from Wayne State University, and it's like very glad to see you all here, sitting to my listening to my research here. So I'm going to talk about a portion of my research, basically focusing on understanding the relationship. I had this starting because of the fact you will see what my research is about. So it's like understanding the maternal environment, metabolic health, and how it impacts the pregnancy outcomes. So I'll start my talk with a little bit of a background. I know I don't have to, I was just discussing with Len and Carol, I don't think I need to give a little bit of background even to this crowd, because everyone is in the same field, interested in knowing more about environmental and stressors for the mothers. And so I will give a short background which is related to my research, why I decided to go on this way. Then I will discuss 3 short stories, basically. 3 different cohorts, 3 short stories, but the main connection is that all about pregnant mothers, environmental exposure, and how the metabolic factors and or physiological factors affected by this exposure. So I'll start with the circulating levels of PFAS, basically, per and polyfluoroalkyl substances with the inflammation and gestational age at birth story. So preterm birth is, we are in the D plus state, basically, and along with Ohio and some other Midwest states, basically, in terms of the preterm birth. So it's above like 10.5 or something in all these states, which are yellow. And then luckily we are not F, but still D plus. And then in terms of the data from Michigan from March of Times, in 2023, 1 in 6 babies were born preterm in Detroit, and then the rate of preterm birth in Detroit is highest in Black infants, about 15.8%, followed by white, and then Asian Hispanic Islanders and Hispanics. So the compared to singleton birth, multiple birth in Detroit are 5 times more likely to have preterm birth in 2022. So the maternal environment actually plays a very crucial role, leading towards birth outcome if there is something imbalance or something happening during the gestation or something. And it's built around a lot of factors. And one of the factor which I will discuss why I chose PFAS were because we'll get to it, but were found to be related to lower birth weight in the echo cohort. And I know a lot of you might have already be working with the echo cohort and large cohort, and other US cohorts have shown influence on the birth outcomes. Then research studies have also shown association of maternal exposures with inflammation and preterm birth. So my hypothesis behind this small pilot study from my K-12 was environmental exposures to PFAS lead to adverse inflammatory state, which is one of the pathways responsible for preterm birth. So pregnancy is very different from the normal metabolic and physiological state, because there are a lot of adaptations a mother's body take in physiological and metabolic, including respiratory, cardiovascular, renal, immunomodulation, which are local and systemic, both of them. And why I chose inflammation was the fact that inflammation itself plays a critical role. At the start of the pregnancy, there's a slight bit of inflammation is needed for the implantation and proper growth of the baby. And then there is a phase where we need lower inflammation levels for the proper growth of the baby, and we don't want too much of the inflammation and markers going on. And then this balance is very important and critical. And towards the end of the pregnancy, like during parturition, we have some factors increasing in the inflammation for the labor. So if there is higher inflammation, and it can lead to the state where the maternal body will have higher cortisol, higher other adverse factors, which can lead to adverse birth outcome and preterm birth, fetal growth restriction, and metabolic and connective tissue disorders. So now the question is why I choose PFAS. I could have chosen other things. I know a lot of researchers are doing a lot of PM 2.5 and other studies, which is very particular, important for the Detroit area. But I was interested in the PFAS because of the fact it is ubiquitous in nature. It's present everywhere, and the people can be affected by using normal consumer products like microwave popcorn bags, personal care products, and like fast food containers and all those. And along with that, we are also exposed to PFAS through environment where we live. There are a lot of industries for firefighting. Foam can have a lot of PFAS, and then a lot of like other sources like wastewater, biosolids, domestic waste can all leach into our water system, rivers, food system, and all those things, drinking water and all those things. So it's kind of like a full environment where we are live in, and we can be exposed to these PFAS level. And I think we remember the time when we used to have oozing foams around Detroit area, and those were PFAS linked to like the firefighter fighting foam or something. And so this is something which I got my interest, and I want to know more and the effect on certain populations which I am interested in. So, and hence have been measuring PFAS since 1999 to 2000. And we can see a drop in PFAS and the ones which are being phased out and not being there, but because of their long half-lives, they are still in the environment, and we are still being exposed, and we might be getting the harmful effects of them. So the PFAS have a toxic effect. Research have shown that it could be related to kidney disorders, higher cholesterol, immunotoxicity, changes in liver enzymes, and all those things. There are certain factors which can affect persistence and bioaccumulation. And I will come towards the end of the talk, you will understand why I'm more interested in bioaccumulation. So I'll just leave it right now, but there are certain factors like CF bond is like carbon-fluorine bond is highly stable. Legacy PFAS, long chain PFAS are still in the environment because of their long half-life. Legacy versus new PFAS, new short chain PFAS. So although they are not as bioaccumulative, but they are in the environment because of their shorter structure and their persistence in the environment, it's hard to remove from the water and other sources. Then in the food chain and systems, like there are links available for the Eat Safe guides from the Eagle and like all those resources available for us. So now why in Midwest, upper Midwest communities? So reports of higher PFAS in drinking water in Michigan and upper Midwest communities are there. And then there are 331 PFAS sites in Michigan late when I was listening to the seminars by the late 2025. And the high underground water contamination in Detroit, we don't know the health consequences in these communities. Then in addition, communities in Detroit and similar communities in the Midwest experience more of the environmental exposure and stressors. So if the body is stressed, they might have more of the effects basically in terms of like how they will react, the biological response, which is like, I'm not a toxicologist, obviously, you can all say, but the biological response might be more exhibited or something, and so we want to know more about it. So the first study, which I'm going to talk about a little bit, is about biosocial impact study. This is a cohort, Wayne State, based in Wayne State. We started the study here. That's why I was at AdBio too with this study. And it was about social stress and inflammation, and it was mixed method approach. And we collected data and samples from multiple sites, but the two sites before COVID were Detroit and Columbus, Ohio. And in Detroit, we had two, one in Southfield and one in Detroit. And the woman completed questionnaires, around 30 to 40 minutes questionnaires, and her blood drawn at the prenatal visits. And I took the sample of 103 women from this, 67 term and 36 preterm for my pilot study, for my research. So in Detroit and in these communities are predominantly Black, and so these women have higher risk of having preterm birth compared to other racial ethnicities and ethnic population. So what do we know about this specific cohort and preterm birth? So, and the inflammation in these women, basically. So I will just go through swiftly with the studies which are connected to the study I am doing. This was a study which shows psychosocial behavioral factors affecting inflammation among pregnant women in this cohort. And the findings were that we had higher IL-6, IL-8, and TNF-alpha with a higher BMI, higher CRP levels with the depressive symptoms, high IL-8 level with the intimate partner violence, and lower anti-inflammatory IL-10 levels, basically. So, so we know that there is something in the inflammation going on, and I can talk a lot about CRP in these women, but I will not distract you girls, so I'll just keep it simple for now. Then we try to find out the lipid markers of preterm birth and what are the relationship with the lipid metabolism in preterm birth. So what we found that preterm birth and term birth were different, And we found actually some of the phosphatidylcholine markers to be lower and specific triglycerides to be higher in preterm birth group. So then the question is, triglycerides are related to BMI, so why we should investigate BMI? What are the effect of BMI on this lipidome profile? So we found that the triglyceride related to the preterm birth were very different from the BMI related triglycerides. In addition, we found a marker, PC16, which is related to inflammation and a lot of other health outcomes, including like poor like a survival rate or something, mortality, sepsis, and in asthmatic patients they have high elevated levels of this. So it is like a kind of like a thing which happened, which shows that the impact of BMI can be very vast or could be very different. So while I was doing this research, I tried to look at the data, and I was not able to find any references to Black women cohort monitoring the lipid profiles throughout the pregnancy. So I have to do this research myself, and I wanted to know what are the normal patterns. And then what I found was that most of the lipids actually increased during pregnancy, and acyl carnitines decreased during pregnancy, and there are some other lipids which if you are interested, we can go back and discuss about it. But the most interesting finding is that there is something happening in the middle of the pregnancy. So what is happening was non-essential fatty acids were higher in the beginning of the pregnancy, they were lower in the middle of the pregnancy, and they went up in the later part of the pregnancy, basically. Then we investigated them in a transcriptome and methylome to investigate the signatures of preterm birth. And what we found was most of the immune function immune tolerance, fetal adaptation, and all those things were related, the genes were related to this kind of like in the methylome. And so we found like HLA-DQB2 gene was both differentially methylated and differentially expressed between the women with the term birth and the preterm birth. So coming back to our study on pilot study, I have to go back. Yeah. So for this pilot study, we had the maternal characteristics of like women had the mean age of 27.6 plus minus 5 years of age. 51% were employed. Majority had high school and education or higher. 56% had annual household income of less than 20,000. And we had like, 43% had less household income less than 10,000 actually. So we took this actually cohort is very rich in data. We collected a lot of information in surveys and also collecting data from the medical health records, basically, which is in progress right now. So we perform, as the study name suggests, social stressors and inflammation. We had the inflammation panel, which is very in-depth, multiplex assays already done. So we did the PFAS assays and try to find out what we can see in terms of the health outcomes. So in my data, we found 3 of the inflammation markers, in IL-6, IL-8, and macrophage inhibitory factor, MIF, to be most related. And they are related to PFDEA, and they are related to PFNA, they are related to PFAS, PFOSA, and PFUA. And then we also investigated the preterm birth and gestational age at birth. So what we found is that preterm birth and gestational birth both were related to the MIF, and IL-6 gestational age at birth was negatively related, and preterm birth showed a trend basically of positive association in this. And in terms of the PFAS with preterm birth, we found that gestational-aided birth has negative association with PFDEA and PFOSA and PFUA. The preterm birth had significant association with the PFUA, but did not reach significance for PFOSA, but there was a trend like less than 0.1, basically. So this part of the data from this pilot study from cohort shows there is an increase in inflammation with the exposure to PFAS, and it could lead towards like adverse health outcomes and pregnancy outcome for these women. So my overarching goal is to integrate this with the more exposures and factors available in this data. So this is kind of like a project which I'm working on right now, and then we can do modeling and dimensional reduction and see if we can see some patterns in it. So what next is that medical record abstraction. So some of you might know Rhonda. She was sitting at me on the conferences as well. So we are working on the medical data to be like, it's almost done. It's just cleaning up stage. So we can have like birth outcome, birth notes and all those things available, and integration with the lipidome and social factors is the next step for this. So this is in process. Now the question was, now I'm going to start the new story, basically, in a new cohort. So I wanted to know more about what are the effects of PFAS on the baby's growth. So that's why I wanted to know that if it is just the birth outcome, inflammation, how the baby is affected. We know some of them are like in the are bioaccumulative and all those things. So I use this cohort, which is like a gestational regulators of weight cohort. It's called GROW, and is a very well characterized cohort to measure the baby's growth at 5 time points. So we had ultrasound and surveys and all the data and samples for this cohort collected at 5 time points, basically. And the participants were recruited at prenatal visits at the University of Michigan, and we had follow-up for 5 time points for this. So for this pilot study, I had 30 women, pregnant women, 25 white and 5 African American, and then age 30 plus minus 6 years of age, and then household income was like divided, but you can see it's more of the quite higher, toward higher side, and we don't see that many of the lower income thing. Like we had 8 of them lower poverty line basically, and then rest of them were above. So our hypothesis was gestational exposure to PFAS lead to a perturbation in mother's metabolic and physiological state by disrupting the pathways of relevance to adverse pregnancy outcome, affecting baby's growth during pregnancy. So for this study, we had ultrasound data, serum, and surveys available. We did the proteome and profiles and PFAS analysis. The same panel was used, the 9 PFAS, and we integrated the data to see that how you can see after dimensional reduction and think if there is any better pattern biomarkers or something. So first we'll start with a bivariate analysis with this birth out like PFAS levels in the circulating PFAS levels and the baby's growth. So we saw that two of the PFAS are like sulfonamides were more affected in the negative way, basically. So 2 of them were negatively associated with baby's growth, basically. And then we saw PFDA, PFNA, and then PFUA were positively associated, so with the baby's growth markers. So I know these are like CRL1 mean crown rump length 1, CRL2 mean crown rump length 2, abdominal circumference at the 3rd time point, head circumference at the 3rd time point, femur length at the 3rd time point, biparietal diameter at 3rd time point. So these are up to 3rd time point, but I do have data for 4th and 5th time points as well, for which will be in it. Then we have a PFOSA. We found that this specific perfluorooctane sulfonamide basically was specifically associated with the crown rump length at the 2nd time point negatively. We also saw this specific PFAS to be associated with a trend of negative association with the preterm birth in the PIP cohort and also in the GROW cohort. So this is a consistent finding in this, and then the negative associated with the crown rump length. Then the acetic acid, like methyl sulfonamide acetic acid, showed negative association with multiple PFAS the fetal growth markers, basically, as we saw in the. So I wanted to investigate this more, and I chose the proteome because it's more of the phenotype first approach, and it can give you the true, like picture, like metabolome and proteome are the two which are phenotype first and give you the picture of the physiological state, basically, and a snapshot of the physiological state. So, and I use the dimensional reduction models where I use the latent variables. The latent variables actually summarize the information in the few latent variables, and we are not analyzing each variable one by one, so they are low FDR and high power in this model. They can handle missile data and no loss of information is there, and it can identify overview trends and patterns in the data. And I also use these S-plots because when you have big data set, we have seen the PCA, principal component analysis, but in the OPLESDA model, which are supervised models, you can make these S-plot, which give you the data overview. And these are like, if you see the red square, the rectangle in the middle, these are the ones which have low magnitude and noise and all the intensity closer to the noise level. So these are not R markers, basically. The R markers are basically on the lower left corner and a higher top right corner, basically, which have higher magnitude and higher. So this plot actually model the covariation against the model correlation to identify the most higher magnitude and higher these significant markers. So I'll be using these plots to identify some of our markers for these PFAS compounds. So I made the model for our PFOSA, and then the marker protein signatures of PFOSA were related to showed positive association with the fibrinogen beta gamma, and this was linked to adverse birth outcome and preeclampsia. And then there were some other proteins which were like related to placental and immune function, immunoglobulin, and a lot of immune function was affected. And then some of them were related to oxidative stress markers. Then the protein markers which showed negative association with PFOSA were like histone, like epigenetic regulation markers, SUMO, which is embryonic development marker and linked to severe malformation if there are lower levels. Then apolipoprotein and lipid transport. And then we have some of the factors which are VSPS and 10 domain containing receptor, which is related to growth factor and placental brain development. So negative regulation and with this one. And then pregnancy specific beta glycoprotein, it is increased during pregnancy and it might be decreased with the higher level of PFOSA. Then insulin signaling also were there. Then we did the markers for our acetic acid one, and we found that it has positive association with the DMK like protein, which is very important for the organogenesis, and then another one which is related to the immune regulation. Then we have protein markers with negative association with included the placental dysfunction, and then the lower levels related to the placental dysfunction and immune system regulation. This hormone, choronoic somatomammotropin hormone 1 is a placental hormone important for fetal growth and metabolic adaptation, and lower levels are related to fetal growth restriction. Another one, isoleucine T RNA transfer RNA ligase cytoplasmic protein was also related to IUGR. So, and then immunohistocompatibility complex was also there. So we can, the main point is that these are the signatures which are highly related and highly have higher magnitude of association. Then I had a question in my mind that I want to know if there are any shared and unique structures in the lipidome, in the proteome with this baby's growth. So I made the model with the abdominal circumference at third time point, and what are the factors and proteins related to this abdominal circumference. And then I made the models with the methyl PFOSA acetic acid and also the PFDEA. So these, as you remember, these are the two which shows opposite direction of the association with the growth markers. The PFOSA ones were showing negative association with the growth markers, the PFDA were showing positive association. And when we made the this shared and unique structure model, we saw that the PFDA showed more association with this abdominal circumference than the unique structure seen in the PFOSA compared to this. So the more structure aligned is more of the in the diagonal along the line, basically. For the future of this is the multi-omics again, and I am receiving the data from metabolomics right now. So it's like 30 samples, and which I have the data for metabolomics. So it's going to be multi-omics with the metabolomics and proteomics together. Then for future direction is preeclampsia pilot. So as you see that a lot of proteins which we identified as markers of the PFAS exposure were related to the immune function and linked to the preeclampsia diagnosis or something. And our pilot was not designed for that. We were designing for the preterm birth or baby's growth and all those things. So we want to do a pilot on the preeclampsia. And then immune system, PFAS and preeclampsia are important. And and also this topic and information is very important for the community as well. So I'm partnering with Rhonda Daly here, and then she is going to be the lead on the community side. I'll be working on the PFAS and like protein markers and all those things, basically. So we developed this hypothesis, and then we are working on this to be working on this. We are excited to be working on this project, basically. We will be measuring PFAS, we will be measuring protein profiles, we will be measuring at 2 time points, because in my data also I saw that there is a decreasing trend or something, so we want to capture that as well. In addition to that, as I was talking about BMI and all those things, we always have a cofactor, covariate as a BMI as a cofactor, covariate, and we control for this in the models. But in pregnancy, actually, as I was discussing, women have higher susceptibility to environmental exposures, and then higher BMI actually can act as a additional stressor, because a lot of PFAS and other chemicals are obesogens, and they can accumulate and have higher bioaccumulation. And so the biological response might be higher or lower. So I also have made the models for the BMI, and the protein signatures which were positively related to BMI were related to immune function, and CRP was one of them, and placental function, apolipoprotein metabolism, and baby growth markers. And the negative association with placental function and adverse birth outcome measures were with the higher BMI model. 2 of the PFAS, these were like PFAS is also one. It's considered as very persistent. Like it was previously a lot more in the like the PANs and all the things. We used to use it basically a lot. And then PFHPA were negatively related to BMI in our. But this negative relationship is like dependent on how much we see and how much is bioaccumulated. So we cannot say much about it basically. But they also show positive association with the gestational age mark. So gestational age was longer when these 2 markers were higher. And then the PFHPA, the protein markers were lipid transport, metabolism, immune system, and immune tolerance, and the negative association with embryogenesis and fetal growth and immune response. With the PFHS was like immune function and adaptation for the positive, and the negative were bleeding problems and baby growth and protein transport. So these were something. So as I'm talking about BMI, I want to talk a little bit more about this metabolic thing about the BMI, maternal BMI. So so I wanted to investigate biological response to exposure and stress, basically. So this is another cohort. This paper is under review right now at environmental research, and hopefully we'll get the good positive result. It's under review, so it's a good sign. So early pregnancy targeted exposome association with biological response markers and the impact of maternal BMI. So I know there is a controversy. Should we call it cumulative? Should we call it additive? Should we call it like Co-exposures, I will go with co-exposures. Basically, we all are exposed to multiple exposure at one time. We don't get exposed to single chemical at one time. So that's why we use the targeted exposomic approach in this, and we kind of like I use the sample and data from Michigan mother-infant pair study, and PI is Vasanta Padmanabhan, and these are samples were collected at the prenatal visit at University of Michigan. And this was also, we tried to have a mix of all the racial representativeness. So we have majority of them were non-Hispanic whites, but we do have African-American 21, and then we have 10 of them Hispanic, with more than one race. So it was like a nested case controls trial kind of a thing where we have like 55 of them have higher BMI and 64 of them have lower BMI. And we kind of like measured 10 classes having 16 subclasses of chemicals, and we measured like 4 biological response markers. 2 of them were oxidative stress markers, and 2 of them were stress, cortisol, and cortisone markers. Then data was, for the exposome data was normalized to urine creatinine levels, because this is the urinary levels. And for most of the chemicals, except for the PFAS, urinary levels are more appropriate to them because of their bioavailability and all those things. So then bivariate and dimensional reduction partial D-square modeling was performed on this data. So we saw there were like some at the class level data, we saw some of the classes, we saw lower urinary levels like volatile organic compound in higher BMI group, parabens, and then phytoestrogens. Others, couple of them shows negative, like the lower levels, trend of being lower levels. And these were the individual chemicals which showed negative association with the higher BMI. So I want to discuss here that lower levels of these may be a result of in the hyperfiltration, which is normally present in obese people. It could be bioaccumulation, we don't know yet, but it could be more accumulated there. But what we saw next was more important. That is, on the left-hand side, you have a low BMI associations with the chemical classes and biological response marker, oxidative stress, and glucocorticoids. And on the right-hand side, you see the high BMI. From just by looking at it, you can see there is a higher correlations, positive correlation going on among the different chemical classes, and also with the oxidative stress and glucocorticoids stress markers. We found that the classes phytoestrogen, polyaromatic hydrocarbons, including, and then some of them were related, showed higher magnitude of positive association. So one thing to realize is that all the chemicals showed positive association with the stress markers. There was no negative association. All of them were leading to, but there was a higher magnitude of positive associations in the higher BMI group for these markers, and also higher magnitude of positive association with the other chemical classes. Again, this is an observation study. I have not done a lot in the terms of measuring and doing the biological response in that thing, but this is what we have observed in this study. Higher magnitude of positive association with UV, but UV filters, flame retardants, phthalates, and showed higher magnitude of association in the low BMI group compared to the high BMI group with oxidative stress in low BMI group. So now comes the interesting part. So then I did the partial least-square modeling, which is dimensional reduction models, for looking at the regression and trend. So the chemicals were positively related with the glucocorticoid markers and in the low and high BMI group. But on the right, if you see, their pattern of association of the chemicals from different chemical classes was different. So what are these classes? That if you see that in the low BMI group, we have the highest with the polyaromatic hydrocarbon. And one thing I want to mention here, the scale for the low BMI is ending up to 1.8, and for the high BMI is ending up to 2.2. And these are VIPs, which are variable important in projection. So higher the VIP means higher importance and contribution toward this association with the glucocorticoids. So we have the difference in pattern of association in the high and low BMI group. In high BMI group, we have polyaromatic hydrocarbons and then insecticides and all those flame retardants. But in the lower BMI group, we have highest association with phytoestrogens, which are obesogens too. They can bioaccumulate too. And then one of the phthalates, volatile organic compounds, and tobacco metabolites. So these are like, we see the difference in the patterns of association with the glucocorticoid markers. Then we see the differences with the oxidative stress marker. The similar trend was seen that there were differences in pattern of association, meaning how much they are contributing towards the association of with the oxidative stress markers. And then the classes of chemicals, which were, by the way, the individual chemicals are listed on the side, basically, which are on the top, basically, and with their thing. And again, the phytoestrogens were highly related, and then fungicides and volatile organic compound and polyaromatic hydrocarbon were more related to the oxidative stress in the high BMI group. Then we investigated with the birth outcomes. So we did that association with the birth weight and gestational age at birth. And I know this graph looked dramatic, that it is positive association in the low BMI group and negative association in the high BMI group, but it did not reach significance at the class level, basically. And only the antimicrobials were positively associated in both the groups with the gestational age at birth. But at the single metabolite or analyte level, at in the chemical level, there were a lot of compounds which were negatively associated with birth weight in low BM, in high and lower BMI group. So the hydrocarbons, pesticides, and showed positive association with the birth weight, and then the two of the smoke compounds, which were narcotinine and the hyperbaric or the hydroxy pyridyl and butanoic acid, showed negative association with birth weight in the low BMI group. Then we have in the high BMI group, we only see a lot of negative association with the VOCs and HPMA, phthalates and phthalate alternatives, and then pesticides. And so this was significantly associated. So we saw that the individual level, individual analyzed chemicals have more like significant associations, although at the class level we see a trend or like a thing. So now, just want to discuss a little bit about the findings. These highlight the complex relationship of maternal body mass index with urinary exposome. And what we want to, I also discussed a little bit about it, the inverse relationship with the urinary exposome is not, so it might mislead at some time based, if we don't do the biological response marker and checking with the biological response, what is the biological response in that case. Then the difference in pattern of association of exposure with the oxidative and glucocorticoid stress markers, and in birth outcome between low and high BMI group can indicate differential impact, and also the higher magnitude of positive association of several exposure classes and individual analyzed with stress markers is suggestive of greater susceptibility. So it is just observational study. I have a lot of limitations. I cannot say anything until we do something in mechanistic approaches in the animal models or organized models, so we have to go through that. So I want to emphasize at the end of this study detail that we also measured the lifestyle factors, and we didn't find any difference between the lifestyle factors. Like we had the questionnaire asking them about their use of cosmetics, use of canned food, use of exposure to living near the landfill, all those things, and there were no kind of like differences between the women we have for the higher and lower BMI group, basically. And still we see the differences in their patterns of associations with the other chemical classes, as well as oxidative stress and biological and the glucocorticoids basically, which could lead towards the differences in the birth outcomes. So as I mentioned that I have for the mechanistic details and going into details, we have to do the translational studies with the maternal exposures and developmental programming studies. And I was part of like a lot of translational studies with the prenatal testosterone and bisphenol A. I'm not going to go into detail, but this is the way, the next step after this. These are some of my papers which are, and I think because a lot of the PFAS and exposure compounds and chemicals are endocrine disrupting in nature, they might be more, it might be more informative to go in depth and look at the exposure through. There is a recent paper which investigate the relationship of steroid hormones with the lipidome profiles and stuff. So that's kind of like thing. So I would like to end my talk here, and I'm open to question if you have any. Thank you so much for inviting me.
Thank you so much, Nadia. I have some questions, but I'm going to hold off to see if we have some other folks here that want to pass by some questions, since many people here are more of an expert in the subject that you were talking about than I am. So, how about anybody have any insights or questions they want to present or ask? Yeah, Mackenzie.
Thank you for your talk. When you said you assess lifestyle factors, I was wondering what kind of dietary assessment tools you use to account for nutrition?
Yeah, so this was already a cohort which was there. This survey is very preliminary survey, but I do have data from other cohorts which have measured the dietary recalls, 24-hour dietary recalls, and those kind of, but this particular study which is under review, we didn't have any dietary recall for them. So we do have like a frequencies basically. How many cans and how many fresh fruits or vegetables, how much that time fast food or something, but not, I'm a nutrition and metabolism background, so I know this is not a standardized tool, but I do have access to some of the 24-hour dietary recall or the food frequency adapted for the pregnancy, so not in the study.
Lynn, I saw your hand up.
Yeah, we had some questions in the chat. I'm just going to unmute so everybody could hear me in the Zoom, if that's okay. I wasn't expecting to hear myself. But Dr. Liu, he asked, have you looked at the circulating PUFA level and mother/placenta/children health? And there's some more questions after that, but if you want to address that one first.
So we have, for these two cohorts, we have measured PFUA, definitely, but we have not looked at the placental part of it. So for the first cohort, I know we don't have access to placenta, but we might have access to placenta in other cohort, but I have to look for it. But no, and we have not measured the placenta level or something. Just the circulating levels.
I see Dr. Liu. It looks like you're ready.
Yeah, I guess.
That works too. Okay.
I guess I could just speak for myself. Thank you so much, Nadia. This is a great talk. I was about to ask, the circulation PUFA level, because you did like lipidomics, right? So, are you able to look at the circulating PUFA level, whether they associate to any of those, pregnant women's health or placenta health or children's health?
PUFA was like one of the, I think I have, you are talking about the PFUA?
Not PFAS, right? PFUA means polyunsaturated fatty acid.
Okay, you're talking about the fatty acids. Like,
Yeah,
so we just had the lipidome study, which
Okay.
showed that normally we have a reduced level during the mid trimester, and then we have the higher level toward the end of the pregnancy, maybe because of the brain development, maybe because of the higher needs towards the end, but we have not investigated that in the relationship with any adverse outcome yet. So that's next to come, basically. That was a study published 1.5, 2 years ago, basically, and that's in the process, basically. When I integrate the PFAS and the lipidome together, we will have that.
Sure, sure. Thanks. I have a second question. So I saw, you showed very interesting data about PFAS, and those either pregnant women or the children health, which is very interesting. I think, my question is, since the PFAS is always a pool, right? So like a mixture. Have you considered other like the models like
It's
the Bayesian kernel model to
Yeah,
look
so
at
yeah,
either
we can
single or
all
pool?
those models are in process. Like yeah, we want to do that models, and we are in the process of having those are done. But one thing I want to emphasize why I kept the separate individual levels PFAS data, because of the fact we were seeing that each individual were differently related to inflammation marker or the baby's birth growth markers. So yes, definitely we'll do the mixture models and also the dimensional reduction modeling for that too. Yes.
Yeah, yeah. Thanks. The third question for me, sorry for my questions. So,
No, like
so I saw some of the analysis actually involve you might have a longitudinal data available, meaning that some of the circulation level for exposome data that is collected during the pregnancy, while you also have children health. Were you able to consider the like a longitudinal design for a causality inference right here?
Yeah, so for my new, I have developed like a R1 proposal, and we are in this pilot also we have 3 time points, and we are going to analyze that. And in the R1 which I've developed, it's like a longitudinal design, because I mentioned like we also saw that there is a reduction in the levels of PFAS with the progression of pregnancy. So all these things I cannot like able to show all the data here, but like that's in the process basically. Yeah, we have longitudinal design with 3 time points basically.
Well, thank you so much. Congratulations for all the good data right here. Thank you so
Thank you
much.
so much. Appreciate that.
Thank you for those questions. Lynn?
We have another question from Navisa.
Hi. Oh, I can hear myself. Okay. Thank you so much for your talk. I just had a question because there's been some more recent studies coming out about the impact of the father's health on the mother's pregnancy. So I was wondering if, like, in the future, if you're going to look at how the father's health might impact some of the markers, like if a certain marker might be common when the father has diabetes, if he smokes, if he's older, those sorts of things.
That's a very good question. And you know what? The BIB has a sister study, which is on paternal impact or father's impact. And we recruited those fathers alongside with these mothers. So that is going to be when we had all the medical data abstracted complete. And then we will be able to look at if they are some fathers and then some, because it's going to be more towards baby's growth and also the father, like the birth outcome measures and stuff. So yes, that's in plan.
Cool. I look forward to seeing the results. Thank you.
Thank you.
Yeah, fantastic question there. Any others, Lynn?
Not right now.
Any others in the room? Well, I will hold off on mine and ask those individually. And I would like to thank you all for being here for this seminar today. Thank you very much, Nadia.
Thank you.
And we will close this now, and I hope everybody has a wonderful afternoon. And how about one more set of hands for